For section 8.5, we're going to get to back to solving trig functions. We're going to find ourselves with some quadratic style functions in here, and using our properties that we learned from simplifying expressions the last couple sections ago. We're going to see if we can come up with the answers to these things. So these first two slides are just a little highlight review of what we've covered over the last couple sections. So we have our reciprocal functions. We're going to be using these relationships to set up these solving trig function problems. And then we have our odd-even identities. Remember that for the sine and tangents and then their corresponding reciprocal functions, when you rotate as a negative angle, you get negative values of those trig functions. Whereas in the cosine world, a negative angle rotation still puts you in a place where cosine is positive. It's the same thing for secant. Then we looked at our Pythagorean identities, and we said if you really just commit to memory cosine squared plus sine squared equals 1, you can develop all of the other ones from this. And then cofunction relationships, remembering that the sine of a 30-degree angle is the same as a cosine of a 90 minus 30 or a cosine of a 60-degree angle. And from these, we head off into doing some solving. So paying attention, first of all, to how we're working, whether in degrees or radians. Here we're in degrees. Solving this one. Now, when it says solve, we're looking for our angle theta that produces these results. So the first thing I would do here, realizing that I have squared or quadratics involved. Generally, we try and have quadratics have a 0 on one side. That's if it was in standard form, ax squared bx c, but we don't have that. We just have the ax squared part. So what we're going to do is try and isolate this sine of theta by, first of all, dividing by 2. And then we get sine squared of theta is now equal to 1/2. And remembering sine squared theta is the same thing as the sine of theta squared. So we want to undo this by taking the square root. And when we do that, we get a plus or minus a 1 over root 2, which we need to rationalize. So hopefully we're getting to the point where I actually don't need to show this rationalization. You can automatically just go ahead and remember that it's going to simplify to just plus or minus root 2 over 2. All right. So again, what we are after is we are after the angle that produces these relationships. Remember, those are y over r's. And hopefully you can recognize that those come from our 45, 45, 90 triangle. So plus or minus means we're actually going to be in all 4 quadrants because of that right there. We're in quadrants 1 through 4. So visually speaking, we've got a ratio of root 2 over 2. We're creating the same triangle in all 4 quadrants. So they're going to be the same theta or reference angles. And that's a 45, 45, 90. So we know we're talking about relationships of 1 and 1 and root 2. But sometimes we're in the negative world, so we have angles that allow us to be in quadrants 2, 3, and 4. Remembering these relationships that we can find our theta by doing 180 minus our reference. Or if we're trying to look for our reference angle, we would have 180 minus theta. Quadrant 3, remember, theta minus 180 if we're looking for our reference. Quadrant 4, 360 minus theta. So each of these is a 45-degree reference angle because of the relationships here. So we can say theta 1, which is this angle 45. So we'll call theta 1 a 45-degree angle. And theta 2, which is this relationship, is a 180 minus a 45-degree reference, so it's 135 degrees. And theta 3, which is this angle, also a 45-degree reference. It's 225. And then finally, theta 4, also 45-degree reference, 350 degrees. So those are all the four answers that I would have to produce that ratio for, in this case, the sine. It would have been the same thing for cosine as well. Okay, still working in degrees. Now we see we've got something that looks quadratic. It looks like a standard quadratic form. Ax squared plus bc, bx plus c equals 0. But what's different about it is our x's in the standard quadratic are now really replaced with this cosine theta. So this is one thing you could do. This is a substitution method for solving this. You don't need to. If you recognize you've got a quadratic with the trig functions, then you can just go ahead and factor it that way. But let's just say we're going to let x equal cosine theta. That would mean this is x squared minus 3x minus 4 equals 0. And this one factors x minus 4, x plus 1. And then because of zero product property, we find that x equals 4, x equals negative 1. Now we have to substitute cosine x, or cosine theta back in here. So cosine theta equals 4, cosine theta equals negative 1. Well, cosine theta equals 4 is not possible because of our ratio there. It's outside of our range for a cosine value. But cosine of theta equals negative 1, we know that that happens at 180 degrees. And so that would have been our answer for this one. And you can plug 180 back in and check. Cosine of 180, which is negative 1, square negative 1, you get a 1. And then minus 3 times the cosine of 180, so a negative 3 times a negative 1 is plus a 3. So you have a 1 plus a 3 equaling 4, minus a 4, producing a 0. So yeah, there's checks. Always a good idea to kind of check. Again, working in degrees, a little different now. We have a cosecant involved here, but we know cosecant is the reciprocal of the sine. So what we want to do here is we want to start by seeing if we can get everything in terms of sine. And now what we have is an equation where we have some denominators involved. And because of the denominators, we can choose, if we want to go ahead and eliminate the denominator by multiplying the entire equation by the LCD. Well, there only is one value of the denominator. That means we're multiplying by sine. And now that sine value is distributing in. And we get 2 sine squared theta minus 1 equals sine theta. Now we have the standard form of a quadratic where we want to keep everything positive squared terms, move everything to the left, and end up with a 0. So that we can factor it, or if it doesn't factor, we can quadratic formula. All right, I'm going to do this one without doing the substitute value. I'm going to look at, I have the same trig function, so I know I can break it down into sine stuff. And we know it's going to factor. Well, I know it's going to factor. So we have 2 sine of theta and sine of theta producing 2 sine theta squared. And we have a negative 2 sine theta plus a 1 sine theta producing a negative sine theta in the middle term. So we have our zero product property once again. Sine theta minus 1 equals 0. And solving for sine of theta, we get sine of theta equaling negative 1/2, or sine of theta equaling 1. so negative 1/2. So we're in negative sign world here for this one. And we know that happens in quadrants 3 and 4. So again, a little sketch. We're happening. There's one of my angle. We'll call that theta 3. Call that one theta 4. And we're trying to find out the angle, reference angle that produced both of those. And we know, hopefully we know by now, that the 1/2 relationship of y over r comes from a 30, 60, 90 triangle. And so that would mean that if our reference angle was a 30, then that would mean in quadrant 3, theta 3 would be 180 plus, or 210 degrees. And quadrant 4's angle would be 360 minus, or 330 degrees. So there are two of our answers. And then for sine of theta equaling 1, we know that that happens at 90 degrees. So there are my answers, 210, 330, and 90. A little quadratic work there. All right, now we're in radians. So when we have x's, we're referring to radian measure for these angles. Okay, so I've got now a cotangent squared, and I probably want to think about seeing if I can somehow take my Pythagorean identity and see if we can get something to work here. Let's see. If I want to end up with a cotangent, that means I want to divide all of this by sine squared, and I get a 1 plus a cotangent squared is equal to a cosecant squared. So if I wanted to solve for cotangent squared, for example, I would have cosecant squared minus 1. Well, maybe that's the relationship we want to use over here. So we have everything in terms of cosecants. So I have now 2 times cosecant squared theta, or x, minus 1 plus 3 cosecant of x. And we're going to go ahead and bring the 1 from the right side of the equation over to the left. Then we go ahead and we get 2 cosecant squared theta x minus 2. And then have some like terms to mess around with here. 2 cosecant squared x plus 3 cosecant of x. Negative 2 minus 1 is negative 3. And we end up with this. And I don't think we can factor that guy. So what we should do is, let's go ahead and do quadratic formula. So we're going to say that cosecant of x would equal negative b plus or minus the square root of b squared minus 4 times 2 times negative 6. So we're going to actually have plus 24 all over 2 times 2, or 4. So we get negative 3 plus or minus the square root of 33 all over 4. Those are what my cosecant x values are. So we have two answers, negative 3 plus the square root of 33 all over 4. And this, we'll just go ahead and make everything decimal, 6.74. We also have that the cosecant of x is equal to negative 3 minus the square root of 33 over 4. This gives me negative 2.19. supposed to be 0.686 on this first one. Miscalculated there. Okay, so we have our answers for cosecant of x. And then we're going to go find out what our angles would be. So we have two values where my cosecant is positive, two values where my cosecant is going to be negative. All right, so we got to switch our gears here to sine. So if the cosecant of x is equal to 0.686, then the sine of x is going to be the reciprocal of that, which I think is 1.46. And over here, sine of x would equal the reciprocal of negative 0.46. All right, so we got a little bit of a problem here. Again, can't have our sine or cosine ratios outside of the range, so those aren't going to work because I have a 1.46. So I'm looking for negative sines again, the radian angles that produce this negative ratio. And call that one theta 3, and then all the way around for theta 4. Well, let's find our reference angle first. We're going to do the inverse sine of a negative 0.46. Make sure our calculator is in the right mode. We would do inverse sine of negative 0.46 and get a negative 0.48. Well, our absolute values, when we're thinking about reference angles, thinking about absolute values. So our reference angle is 0.48. So that means in quadrant 3, for theta 3, we would do our pi radian plus 0.48. And this makes 3.62. There's one of my angle thetas. And in quadrant 4, where we would have 2 pi, or 6.28, minus our reference angle, we would have 5.8. And there are two values of theta in radians that would satisfy the solutions to this problem. A little more work involved with that. All right, solving again in radians, sine squared x minus sine x equals cosine squared x. Okay, so I'd like to get all these to be the same trig function. And I see sine x squared, and I see sine x. So let's see if we can create out of a cosine squared x a sine x. Well, we know our identity says that a cosine squared is the same thing as a 1 minus a sine squared. So that's what we're going to do. We're going to replace cosine squared with 1 minus sine squared. Now everything is in terms of sines. Let's bring all the parts over to the left-hand side. Add sine squared x, we get 2 sine squared x minus a sine x minus a 1 equals a 0. And I believe we will be able to factor this one. We have 2 sine x and a sine x and a negative 2 plus a 1 again. Looks similar to one of the other problems I think we had. So we get 2 sine x plus 1 equals 0, or sine x minus 1 equals 0. So we get sine x is equal to negative 1/2, and sine x is equal to positive 1. And then we're in radians, so what's our radian answer for this negative 1/2 relationship? That would be 7 pi over 6. And at 11 pi over 6. And for this one, it would be, for sine of 1, it would be a pi over 2. Check. See if these are